Welcome to all my friends. Today we are going to discuss it is third lecture in online series. So that topic is electro discharge machining. So let me first revise this. In previous lecture, you already learned what is the non-traditional manufacturing processes, its need, its importance, and its distinguish. Then also explain one process is already over, that is abrasive jet machining processes. Now to start the second process, that is electro discharge machining processes. First, it is the non-traditional machining processes and it under the thermal based energy. That's why electro discharge machining, and it is the negative type of manufacturing of non-traditional machining process in which electro means to generate the arc and discharge means that is a spark, and machining means to cut the material under this process. That's why it is called as machining. So shortly says electro discharge machining, so to remove the material by means of spark. So EDM is the process also called as spark erosion process, electro erosion process, thermal erosion process, so on. Then EDM is the one of the most widely used unconventional means non-traditional machining processes. The main attraction of electro discharge machining is that the technique utilizes thermoelectric process to erode undesirable material from the workpiece by a series of discrete electrical sparks between the workpiece and electrode. Discrete electrical spark means, as you already know, that electric current wave as a sinusoidal wave like sine waves, certain amplitude, then delay, then amplitude, and then delay, like this. Means just form the current produce, then again break, then again pass the current, again break. It is like a breakdown. So we'll start the at actual process of the electro discharge machining. So in which every time whatever theoretical question that process to start this principle, try to draw symbolically figure, then its setup, then construction, then working, then process parameters, advantages, disadvantages, and at the last applications. So that subject is theoretical, so that's why every question is to draw the figure, because figure is compulsory for the every question, because when you draw the figures, then examiner can understand this, but student should know the everything. So student start first principle, again similar principle for the non-traditional, which is only to replace that word instead of this energy level. It may be mechanical, it may be thermal, it may be electrochemical, or like this. So this is the thermal based non-traditional machining processes which works on the basis of spark erosion. Student, you observe that is the simple figure for the principal base. Every figure, that is a workpiece and cutting tool. These are the two integral parts of the processes. Now here that hatching parts indicate the workpiece, and now this is the rectangular vertical section, that is a tool. What means that tool is directly contact to the workpiece, because I already said that in non-traditional machining processes there is no physical contact between tool and workpiece. And for thermal base means to generate the heat, that purpose you have to supply the power. So that's why tool and workpiece is connected to the power supply unit. Now next, this is the setup of electrical discharge machining processes. Now just observe this figure. So that figure is not complicated. Just simplified figure. Every time when you start the figure, so first draw the workpiece, then cutting tool. Then for the processes purpose, which devices are used? So that addition one by one. So this figure setup one of the container, and then container in which one is a fixture mounted on the table, and then that fixture fix the workpiece. That fixture means to fix the workpiece. Here also you have to complete directly working. Then this is the workpiece. Now here this is the cutting tool. Then here servo control feed mechanism. So let me explain one by one. Okay. This is the hose is connected to the filter, pump and again to the container. And here one of the block indicate the DC pulse generator or power supply unit. Now here this circular section showing what exactly happens in between workpiece and tool. So student, first write down the construction, then working, then process parameter, then advantage and disadvantages, and at the last application. So in construction, just put the all basic parts of that processes and try to write its function. It's better. Then start the working. Okay. So I would like to say that it is the one of the container in which container fills the dielectric fluid. So what is the dielectric fluid? So this is the fluid acts as an insulator, also conductor. In the process, that fluid known as a dielectric fluid. So which are the dielectric fluids? So oil, paraffin oil, transformer oil, kerosene or distilled water also. Sometimes question may be there to write the dielectric fluids. So you must know that dielectric fluids are kerosene, distilled water, paraffin oil, transformer oil. Then this located in the workpiece on the fixture. Fixture means to fix or to hold the workpiece. Now here this is the cutting tool. This is the cutting tool, or it is also called as electrode. But in this process, that is the main important thing is that workpiece always connected to the positive. That's why it is called as an anode. Then this cutting tool always connected to the negative terminal. Then it is connected to the DC supply. Positive plus negative means anode plus cathode. So cutting tool always cathode, workpiece always positive anode in every processes, all the non-traditional machining process. Then filter. It is a function of filter to remove the impurities, burrs, etc. Then why that pump is provided again in this line? So that pump is the device to supply the fluid from low pressure to high pressure. That purpose that pump is used. Now just start the working in simple way. When DC supply is on, when DC supply is on, so that current should be passed through this electrode. Electrode means it is the one of the conductive material like copper, tungsten, graphite, etc. Then this electrode it's energized means it process the ionization. You don't you know the very well known what is the ionization and what is the deionization. Deionization means it is the split up of molecules in form of certain positive ions and negative ions. Negative means electrons. Okay. So this process, when electric current is passed, so from this tool that split up the positive ions and negative ions, these negative ions it transfer for this positive of the workpiece, because negative ions always attract to the positive ions always attract to the negative ion. So that's why workpiece always connected to the positive, that is anode. Then every process in between certain gap is there, that is a standoff distance also says. It is a gap between cutting tool and workpiece is. Now when electrons move toward the workpiece, so there small gap should be there, and this small gap, that fluids comes under this gap, that means these fluids get energized, and that is the conductor of the electricity from the tool to the workpiece. Then it happens to remove the material in form of spark. That spark is generated, that temperature is almost 8,000 to 12,000 degrees Celsius, just to remove the material from the workpiece. Again, that is voltage is breakdown voltage. So I have said that that supplies a discrete supply means or to form the voltage or current in the form of sine waves. So first pass this supply, again break these. At that period, when spark break, that period, that material gets removed or pass through this fluid, and then again other dielectric fluid flush here again, then again start the ionization, then again start the allow the current from the workpiece to generate the spark. So that pulse are continuously generated, and thus it is to remove the material from the workpiece. So now this dielectric fluid is continuously here by means of nozzle also. So that nozzle is already inbuilt here. Some processes are showing in other side, that is the nozzle, and you know very well what is the function of nozzle. Nozzle, it is the device that high pressure energy is converted into high velocity of kinetic energy. Now here pump is provided because that dielectric fluid is continuously supplied to this process. That's why this pump is to lift or pressurize low pressure fluid is supplied to the high pressure side from this filter, because after removing the material, that material gets flowing to this dielectric, so that's why it need to remove it and then again supply as clean dielectric fluid pass through the cutting tool and workpiece gap. But in workpiece, when removing the material from the workpiece, so certain depths are required, that is the depth of cut. So continuously feeding purpose, that servo control feed mechanism is here, that is also important. So you have to remember how to remove that material. When DC supply is on from the electrode to the workpiece, then it generates the spark, and that spark purpose to remove the material by spark erosion. Okay. And this material gets flew through this dielectric fluid and then again recycle this dielectric fluid. This is the process to removing the material. Let us see next, construction. Already explained that. Tool and workpiece. So you have to also mention that tool is always connected to the negative terminal, that is the cathode, and workpiece always connected to the positive anode. Then dielectric fluid, already said that dielectric fluid, it is a fluid in which having the property has when current voltage is high, then it has work as a conduction, then otherwise it as a insulator. That's why breakdown voltage said. Means when voltage is that, so it is the conductor, then voltage is down, means as a dual period, this is the directly stop and flushing of the fluid in between tool and workpiece. Then RC circuit is there. Third one is RC circuit and power supply. What is meant by RC circuit? R stands for resistance and C stands for capacitor. Means a resistor to resist the supply. Then C stands for capacitor to store the charge. Means whenever required. Because I already said that supply is a discrete supply. Means transfer high voltage again breakdown, again high voltage again breakdown. So that purpose RC circuit is required. Then for continuously depth of cut purpose, that tool feed mechanism is required, that is controlled by the servo motor. Then working, as a working, every time mention first which type of process on the basis of which principle works here. So working processes, so EDM works on the principle of heat energy generated by spark is used to remove the material from the workpiece. Now here electric spark gap is generated to machine the workpiece to produce the desired shape, and the tool and workpiece are separated by small gap called as spark gap. The gap varies from 0.01 mm to 0.5 mm. The tool and workpiece both are immersed in dielectric fluid. So when supply is made on, the thousands of spark are produced per second. That sentence is very important. The thousands of sparks are produced per second. The duration of each spark is very short. Next, when the spark comes in contact with the dielectric fluid in the spark gap, the fluid gets ionized, split up the molecules in form of positive ions and negative ions, and it allows the current to flow between tool and workplace as shown in figure. A very high temperature of around 10,000 degrees is generated in spark region. There is a range near about 8,000 to 12,000 degrees Celsius, and thus the material gets melted and is removed from the workpiece. The melted materials of the metal are then driven away by the dielectric fluid. Thus, material removal rate. Now, we are going to show you that is a process parameter of electro discharge machine. Same, whatever we are discussing in the working, so same write the key points like, so first supply voltage, every process that supply voltage is required, so that it range but not in abrasive jet machining because this is a mechanical base. So wherever electric supply is necessary, so that supply voltage, that point is important. It range between 50 volt to 400 volt DC supply is required. Then breakdown voltage, it is the voltage at which dielectric breakdown. Increase in breakdown voltage result in increase of spark energy. Means breakdown voltage is increases, so increase the spark energy. So how much time is to supply that current? So it depends on this spark energy gets vary. Consequently, the metal removal rate increases, which result in poor surface finish. When spark energy time is more, you will get poor surface finish. Then RC circuit like this. So resistance and capacitance. Increase in capacitance will result in increase of metal removal rate, and decrease in resistance will result in increase the metal removal rate. Now to remember, when increase the capacitance, so MRR is increases, and decrease the resistance, then increase the MRR. In spark gap setting, it is also standard parameter. So gap is more, so you will get poor surface finish. So gap is small, you get better surface finish. So the pulse duration range from 2 to 200 pulse per second. So decrease in pulse duration will result in high tool wear, increases in pulse duration. This is a low metal removal rate. And again more important parameter, that is a spark frequency. It is about 100 spark per second in non-conventional methods. Then just go through this. What is the electrode? What are the materials? We're already discussing, but sometimes question may be there for 2 marks. So first, it should have a good electrical conductivity and thermal conductivity. It's conductive material known as electrodes, and should be easy to fabricate any required shape. It should have high melting point. It should have low erosion rate. So these are the properties of electrode. Now characteristics of dielectric fluid, also that type of question may be asked for the exam. The function of dielectric fluid is to act as a flushing medium for the removal of chips and to provide a cooling medium. It should have good cooling ability, and low viscosity of dielectric produces smooth surfaces, and it should be chemically neutral, otherwise it reacts with the electrode, workpiece and containers may get damage the workpiece. Then it should not produce any toxic vapor during this process. So that's why you have to need that, always checking that dielectric fluid properties for that non-toxicity purpose. Then for example, which materials? So kerosene, distilled water, lubricating oils, transformer oil, paraffin oils, etc. Then advantages of EDM. So every process has some advantages. So first advantage is to create these small holes, very small holes. Then EDM milling to machine complex shape with a simple cylindrical electrodes. So complex shape can be produced. Then EDM process has ability to machine hard, difficult to machine materials. So any hard material can be cut by these processes. Thin and brittle components can be machined without a distortion because there is no contact between the tool and workpiece. And it is very important advantage is no burr are left in machine surfaces. So these are the advantages. Now some limitations are there. So first limitation is the common limitation, that is initial setup cost is very high. Then material removal rate is low. Then this process can be on that taper hole may be there slightly. So here already mentioned that taper holes may be there. And it varies when spark gap gets vary, so that taper holes dimension also varies. So this process can only be employed in electrical conductive material. That material should apply only conductive materials. The energy required for the operation is more than that the conventional machining. Power is required as compared to conventional machining. More power is required. Rough surface finish when at high rate of material removal rate, and finishing cut are needed at low MRR. And profile machining is complex counter is not possible at a required tolerance. And some processes take over these limitations also. And at the last, we are saying applications of EDM. So it is used to produce these small holes for the parts with complex, precise, irregular shape. Forging, press tool, extrusion dies, cutting tool dies, and mold. So, at the exam point of view, to remember any two applications. So, idiom for create accurate dimension holes, deep small diameter holes, narrow slots in turbine blades, difficult to internal shape. It is also used in aerospace and medical applications. Then fourth, internal threads can be produced by using rotary spindle. So internal threads also made by this process. Then it is very important in a resharpening of cutting tools and broaches. Resharpening of cutting tool and broaches. So I hope everyone understood properly. Thank you.